Then we go back to Radnja. We recorded there at different places, near the megaliths and the Saras new excavation point. Sorry, Dr. Ak got this new excavation point during that time. And also in the end of the tunnels where the water section starts. And the basic results were about the same what you just saw, just noise with quite heavy low end. But the interesting thing what I recorded there on the last day of my visit with my recording assistant Richard Hoyle, we recorded an infrasound loop which is originating about 7 till 10 hertz. And here I'm playing the sample for you guys. I have looped the sound. The actual sound happened 3 times, and the first of the 3 times was audible in a normal ear. And the rest 2 were almost impossible to hear, but you can see them in the files when analyzing. So this is the sample which is looped, the first ultrasound, infrasound, and I have tuned it up, so 2 octaves. So as the ultrasound, I'm very speeding files downwards, but on infrasound, I'm very speeding upwards. So this is 2 octaves upwards. For me, original sound files sounded like a big clockwork, but yeah, this is the same for sound of fragment. Then we went to Tumulus of Radnica, and the live recordings with the first method didn't show any special there. There was lots of external noises, like you can read there. Also, we got an idea to use the hydrophones because of the noises, external noises, and also using them as a ground phones, so-called. And this is the visual frequency response from the Tumulus files. So you can see the low end, there's a lot of disturbance, and the middle range. But the high end thing, so-called ultrasound area here is okay, but there's nothing special happening there. And in this point I was making a low pass filter with this machine here. And so it's a little bit easier to investigate the ultrasound area. So this is a recording made in Tumulus. And those are interesting points. There's something happening in, this is about 70 kilohertz, this area. So there's definitely something happening there as well. Then we went up to this top of the pyramid of the sun and used the same method there, and this is the same as a microphone with the windscreen, and we were recording in different places, mostly in those places where Paolo has discovered the ultrasound emissions with the compounder. There's lots of samples from there, but basically there's no special things happening there because of there was like the same problem with the tumulus. There was external noises and wind and stuff. So it's, this method didn't give anything special for us. But when I analyzed these files in Finland with the Pro Tools system, digital audio workstation, and I used the special synthesis algorithms, mono and polyphonic. This is one monophonic and this is polyphonic. It means that there is only one note or several notes. And this kind of synthesis algorithm, which is working inside the Pro Tools, I got some peculiar sounds from the files, so I'm going to play them soon. But the thing, what we should do in the future is to make the hydrophone recordings there. And why, I will explain you soon. This is the sound from the, we could call it the sound of the pyramid as well. One channel, what you heard, it's a stereo file because this, you just heard the sound of the microphone, not the combination. So the sound system here is just playing my left channel, but we can live with that. So it's very interesting sounds with the elastic audio synthesis. There we go, the pyramid of the moon. Between the minefields, and we recorded in this well on the left, and there was also the insects and birds and all the animal sounds were present there and interrupted a little bit, especially the flies in there in the well. They were very annoying, but I used the same synthesis for the files there, and we got this. Yes. So that was the end of my first trip here. Any questions so far? If not, we go forward. Okay. So my next trip, I was a little bit more experienced when I came here second time, and I also studied a few things about conventional musical scales, Pythagorean scales. And also scale based on Earth circumference. I just got this slide a few days ago, so I'm going to study it further. But this is really interesting scheme in a way, and I'll explain. I will tell what this Earth's diameter, for example, here is here 750 2 hertz. And the results would be what I'm going to show you is very near about this frequency. So, second high definition audio was July, and we had 2 aquarium audio XLR hydrophones. So the hydrophone is a kind of a microphone, but it's basically used to in water. There's lots of whale recordings, dolphin recordings, ice recordings in Greenland, and also our good friend military use them as with the submarines. And it's a very high-tech machine in a way. It's small and it's very rough and rugged, yes, tough, and you can dig it to the ground and you can put it to the water, and it's also, it has a very high frequency response from 10 hertz to 100 kilohertz if the recorder can record until that point. Then I also had a DPA condenser studio microphone, and also a different NKH Sennheiser microphone, the same microphone what I used on my first trip. And another digital recorder I took with me also. It was a professional, the best portable digital recorder in the world. So this is the model. Then also Paolo de Bertollis brought a new spectrum analyzer for measuring the magnetic field area with these frequencies, and we just got it during this trip then, and we were a little green with using that, but we did some preliminary measurements with that equipment, but we didn't conclude any results. Process was still evolving with that thing. Maybe Davor can help us with analyzing those data, what we have with that. And it's the analyzer itself is connected to Macintosh computer and also connected to PC, and we made some basic measurements near the megaliths and basically the tunnel around there. And then when during this same trip on July, we our group discovered this object from the ground, and there was I had these equipments with me then, and I made some measurements near the object, and I got this kind of results. So there is this frequency response is from 20 kilohertz until 100 kilohertz, and there's lots of magnetic fields happening. It's millivolts per meter, and as I can, this is a little bit out of my field, so-called, but I hope that in the future we can find more data with this. So, back to my field. The hydrophone recordings, I put the hydrophones to the wrong water section, and that was the thing what we were planning to do with Paolo. And the results were very interesting. Because the sound is moving in the air, as dependent by the temperature of the air, about 340 meters per second. So in the water, it goes from 6 kilometers until 8 kilometers per second. So sound is moving in the water element much more faster, and it's also I feel it's like an antenna to analyze all the Earth's or ground's sounds. So example is that thing with the peaks, and as you can see, this 24 kilohertz, 48 kilohertz, these frequencies are exact 1 octave from each other, and their amplitudes are changing with the pattern, so in the rhythm. So now the example of this with the sound. For some reason I can't play the sound files for you, but you can see the spikes. This is here and 3000 hertz, and this is 6000 hertz, and now it went away and now it comes back, and it does in the rhythm. And this is recorded with the hydrophones in the tunnel in water. So basically, this is interesting phenomenon because that this is musical interval, and also that this, you can see the pattern here. Is when Slobodan Mistrak yesterday or 2 days ago was keeping his presentation, and he showed the first 28 kilohertz oscilloscope picture. It reminded me about this, so they might be related. And this, now here's the sound. So you can hear the high sounds like sine waves, and there's a pattern. This sound file waveform here is a slide of the part of the when there is a change in the rhythm. So it contains also an infrasound, the change, the rhythmical change, and it's very interesting phenomenon, and this is, we are continuing to analyzing these files because we have lots of material to analyze. Then we go back to went to Tumulus, and the hydrophones, I personally dug them to the ground, and the same kind of ultrasound phenomenon like in Radne, water came out from the ground. But there was a slight difference between the peaks, and there was 3 of them. These are approximate values, but the base peak is the same than in Radne. And I have to point out that this, the combination of different effects or the frequencies combining to areas in Dusakov here, it's not investigated yet. So we had to have equipments and spend lots of days here and calculate and investigate what are the other frequencies different in different hills here or pyramids or like that. So I don't know the combination or relation between those frequencies. I don't know it yet. There's one beat, another one, and a third one. And this, this why it goes like this. It means that this my recording system can't record more higher. This is about 80,000 hertz in this point. And it's also noticeable that these peaks in 2 voice brackets, they are not changing at this knowledge what I have now. So, what we learn from this, like Dr. Conchi said before, that all the investigations in every area here in this field is raising more questions than answers. Is the same thing here. So I'm really looking forward to get back to the field and make more investigation with SPRG group, where I'm very proud to be part of it. And in the end, I would like to just play the raw, very original file, which is not equalized or compressed anyhow. This is the basic sound in Ravne tunnel with all the bass and all the white frequency response. So I think this is answering, at least for me, is answering the question: is there something working inside the pyramid? So I think that there is. So after this, I'm concluding this my presentation to thank for these great people, Richard, Sarah, Aileen, Alfredo, Justin, for assistance with doing this thing, and thank you for your attention.